Okay, so let's move on to an exercise. So for this exercise, we are gonna load the T4.8 dataset. This is another dataset people use a lot in the world of the research of the data science to evaluate the performances of the clustering algorithm. And DBSCAN performs very well in this dataset. Okay, so we first below the data, and after that, you can see there are only x and y axis, and I didn't do the standard scalar because again, I find the range of the or the scope of the x and y axis, they are kind of close to each other, so I want to keep the dataset as is. And if you want to uh, check, if you want to count how many clusters are there, so this is a U-shaped cluster, another U-shaped cluster, a T-shaped cluster, and then this one is a separate cluster, I guess, and then this one a bar shape, and then a S-shaped cluster. And meanwhile, this data set is interesting because it also adds a lot of the noise, and then you see there is a cosine curve behind that. So if you track that, you will see that is a cosine curve. Okay, so this data set is not an easy data set, and if you want to try to do the k-means, and you may get some really ugly results. But the reason is there's no a specific shape of the clusters, and there are some clusters have really weird shape. For example, like here we have a T-shaped cluster, right? Okay, so first let's try you need to go ahead and try the DB scan, and you have to make a reasonable guess of the hyperparameters. I'm talking about one, the epsilon, and then two, the mean points. So you have to visualize the data and get some sense, and then do a reasonable guess of of those two hyperparameters. So you may have to try that several times, and after that, you can get the labels. And after playing with the hyperparameters a little bit, I got a total of 10 different labels. And remember, -1 means they are the noise data, and then for the cluster labels, I have from 0 to 8. Okay, the next part, I want to check how many of the samples are noise data. So, I can create a mask, and then I check how many truths and how many falses. So I have 500 false, so there are 500 of the noise data. Okay, and the next part, I want to apply this mask to the dataset so that I can get rid of all the noise data. And if I want to visualize this dataset again, now it is much cleaner. The reason is all the noise data have been removed. Okay, so if you want to check, there are a few very big clusters, and meanwhile there are three very small clusters. So this one is a very small cluster, and this one and this one, they are very small clusters. Okay, and the next thing is, how about we do a value count and see how many samples are there in each of the cluster labels. So go ahead and do a value count, and I know you guys have already learned that in last semester. Okay, and then I want to further get rid of the small clusters. Okay, so you want to find which are what are the cluster labels for the small clusters, and then you also want to get rid of the smaller clusters. So eventually you should get something like this. So we have already get rid of all the noise data, and we have also get rid of all the smaller clusters, so we only keep the major 6 big clusters. Okay, so this is going to be a long exercise, and I suggest you to pause the video here because I'm about to show you my answers. You should try to write your own code first. Okay, so pause the video for now. Okay, so this is my answer. And after playing with the hyperparameters a little bit, I decided I want to do the epsilon as 10 and the mean samples as 15. And of course, you can you should try different hyperparameters and then visually check the results and see whether your hyperparameter combinations make sense or not. Okay, and after that I can get all the labels, and by doing the DB, which is the DBSCAN model name and dot labels, and after that if I want to get the unique labels, and you should get this, well, that's not quite impressive. And how about we try to do a value count? So I can count the unique values, and then I zip them together, and those are the numbers of the trues and the falses. And after that I can apply this mask to the dataset, and then I will filter out all the noise data and move on further. I also want to do another value count based on the labels, and then it will give me how many samples are in the cluster label 0, how many samples are in the cluster label 1, etc. And by doing that, what I can see is for the cluster label 6, 7, and 8, those are the smaller cluster labels. So I want to get rid of that. I want to do another mask checking whether the label number is smaller than 6, and then I apply this mask to the dataset. So I throw away all the other samples if the cluster labels are 6 or higher. Okay, so I do another visualization, and this is what I got. So well, this is the exercise, and let's move on and talk about the cool things and the things which are not so cool about the DBSCAN. And I want you to consider this dataset. So for this dataset, there are a total of 1, 2, 3, 4, 5, 6. So there are a total of 6 clusters. And if you see the clusters, they are all in the round or a oval shape. So well, those shapes are not the big problem. And what is the big problem? So think about that. Okay, well, by the way, before I move on, well, when I see this dataset, I find this dataset looks like a Japanese goldfish. So, well, probably if you have been in United States and you don't have a lot of chance to see this kind of Japanese goldfish. In United States, personally, I have seen that only once, and when I was in Hawaii. And when I visited a Japanese temple, I saw this kind of Japanese goldfish. And let me know if we can see this kind of fish in any of the aquariums. I don't think we have this kind of fish in NC Aquarium at the Fort Fisher. Okay, so let me know. Okay, let's come back to this dataset. So the biggest problem of this Japanese goldfish dataset is, well, for those clusters, the density vary a lot. Do you see that? Okay, so for this cluster, well, the density is really low. And for this one, this is the eye of the Japanese goldfish, and then the density is really high, right? So, well, why do I talk about the density? Well, for the density, well, the density of the dataset or the density of the clusters will determine how you can set the hyperparameters. And when you have a dataset have varied density inside different clusters, you will have a big trouble. So why? Well, for example, if we try the first one, so we try to do one epsilon, and then well, we are able to pick up the left cluster as a loose cluster. However, on the right side, for the body, and then for the 2 eyes and 1 nose, and those 4 clusters will be put together into one cluster. And you may say, no, that's not right. And let's do another way. So if we adjust the hyperparameters a little bit, and then we will be able to differentiate all the eyes and the nose. So those 3 will be 3 different clusters. And however, the body, the tail, the waist, and they will all be considered as the noise data. Okay, so this is a problem because we have a total of 6 clusters, and the density inside of those 6 clusters, they vary too much, and it's not impossible for a DBSCAN to pick up all of them. Okay, so uh, what are what are the pros of the DBSCAN? So for the DBSCAN, we can handle the clusters of any shape. We don't have to assume that the shape of the clusters are round. Okay, and then, well, another thing is it doesn't have to cluster all the samples. That is also good, because if you have a noisy data set and if your goal is to cluster all the samples, the problem is, even for a noise data, you have to assign that to one of the cluster. It doesn't make sense, because if you have so many noise data and then the noise data themselves can change the shape of a cluster. So it is much better if you cluster the samples you are able to cluster. And then for the remaining of them, if you decide there's a noise, you don't bother to cluster that. So that's definitely a good thing about the DBSCAN. And for the cons, well, DBSCAN is sensitive to the parameters. So you do have to try different combinations of the hyperparameters before you can decide which are the good hyperparameters you're going to use. And another thing is it cannot handle the varying densities. If you have a dataset and then you know the clusters have varied densities, and DBSCAN may not work that well. Okay, so for the next part, well, I just want to talk to you briefly. Well, for the DBSCAN, well, you may want to know how fast it is, and then the answer is the DBSCAN. It is the time complexity is the O D M square, and the D is the number of the features, and M is the number of the samples. Okay, D M square, and usually you will have a much higher M than D, which means you will have a lot more samples than the features you have. And then, well, it is a squared time algorithm. So if you want to compare, well, DBSCAN versus the k-means, which one is faster? Remember last time we talked about the time complexity of the k-means? That is, well, we say in practice we can consider the DBSCAN as we can consider the k-means as a linear time algorithm, right? So, well, and for the DBSCAN, it is a square time algorithm. So DBSCAN is slower. Okay, and since we know DBSCAN is slower, this means DBSCAN struggles more with larger dataset. Okay, and in addition, the DBSCAN also has a higher space complexity, because we do have to build a n by n, m by m distance matrix. So DBSCAN is a nice algorithm and it works very well with the spatial dataset. However, DBSCAN is a slower clustering algorithm. Okay, so a very quick sum up. Well, for the DBSCAN, in this lecture, we say, well, in the DBSCAN, we are trying to classify each of the samples to 3 different categories. They are the core points, border points, and the noise points. And well, it is very good for the data set with similar densities. Okay, so well, if you know, or if you feel like for the clusters they should have the similar densities, and go ahead and try DBSCAN. And if your dataset is something like the Japanese goldfish dataset with varied densities, and DBSCAN may struggle with that. Okay, so that's it for today, and I will see you guys tomorrow. Bye.